Welcome all to the Max lecture series. So from this session onwards, we are going to learn how to apply integration for so many variety models. In integration, you might have heard there are so many methods. So after going through all the conceptual methods, when we are entering into problems, directly one problem will be arises for everyone. We don't know how to solve that numerical question. We might have gone through all the methods and we might have understood, okay, if it will come in this model, we have to do like this. But while solving the problems which are related to integration, when the moment we are looking into the question, definitely most of us are not getting the idea. So in order to remove this problem, what we need to do is we have to practice variety of problems. And how can we approach, sir? It will come after solving some 20 to 30 questions. Anyway, my sincere suggestion, in this integration lecture series, I will be covering so many questions. So first, completely watch all the questions before going for practice. Once you watch the complete problem solving session of this integration series, definitely you will get certain idea when the moment you are looking into the questions. So just observe here. So the first question given here is the value of, they have given a certain function, the value of, actually I see myself, I missed the limit. The value of integration limits are going from 0 to infinity e power minus y power 3 dot y power 1 by 2 into dy is dash. So whenever these type of functions are given, like whenever you are observing two different functions with the same variables, like see there e power minus y cube, actually we have to integrate this function with respect to y. Now if you observe, y has been broken into two parts. One is lies in the power of e, another one is lies separately. So whenever you are observing two different places, whenever you are observing two distinguished functions, like for y, actually we are going to integrate this function with respect to y, and whereas I am observing y has been placed at two different position, like in two different format it has been represented. So like that, when the moment you are observing two different representation of your integration variable, what you have to do is first try to solve that equation with the help of substitution method. Sir, what is called substitution method? We know in our childhood problems, like in mathematics questions when we are in 9th standard or 10th standard, they usually told us to keep some other variable. Like if you observe these two functions, here we have to take any one function from these two, and we should give some new name for that, like we can put p, we can put t, we can put q, whatever the thing that you are raising in your mind, you can just put it. Let me show you, you may not get clear idea. So what I am going to do is, here I am going to replace simply that y cube by a simple variable called p. Okay, sir. If I am replacing y by p, then what we have to do is, this entire equation we have to change it in terms of p only, because see there, I am trying to change the y to p. Sir, why are you trying to change it? Because you cannot directly integrate this function, and you cannot directly apply some UV methods also. Then this series will be continuing, you are unable to solve this question. So what I have to do, sir? You have to think logically. Don't worry, by practice automatically will come everything. Though you are not going to practice, just observe the entire integration lecture series. Definitely you will get the idea. Okay, sir. So when the moment I am replacing y cube by p, it is very important to replace all other y parameter by p. And then see there, here the limits were given with respect to y. When the moment I am changing this y variable to p, then limit also need to be changed from y to p. So you have to identify the new limit with respect to p. Okay, sir. Let us continue this question now. So this is the given. When the moment you are replacing y cube equal to p, then how can I play with the other variables? From this, can I write like this? From this I can say y is equal to p power 1 by 3. Yes, sir, undoubtedly. Then on both sides, I am just going to multiply. On the power, I am just putting 1 by 2 on both sides. Here already we are having 1 by 3 in the power. If I am putting 1 by 2 also, then it will become p power 1 by 6. Are you sure? I hope you understood this. So now I can replace this y power 1 by 2 by p power 1 by 6. I can replace this e power y3 can be replaced by p. Okay, sir, absolutely, it's fine. Next, dy is there. I have to replace dy by dp. How can I do that? For that, take the function y. So we know the value of y can be written as p power 1 by 3. Now tell me, what is the value of dy by dp? If I am differentiating this function with respect to p, what will be obtaining? We know according to differentiation, if you are differentiating a function x power n, that will giving you n into x power n minus 1. So here in place of n we are having 1 by 3. So this can be further become 1 by 3 p power 1 by 3 minus 1. So if I am putting 1 by 3 minus 1, take cross product, it will become 1 minus 3 upon 3. Of course this will be equal to minus 2 by 3. So the correct answer is p power minus 2 by 3. From here further we can write the value of dy can be written as simply 1 by 3 p power minus 2 upon 3 into dp. That's all. That is the value of dy. Now it's time to replace the limit also. So we are considering y power 3 equal to p, and the corresponding limits are given as, they have given two limits, y equal to 0, y equal to infinity. It is going from 0 to infinity. Now tell me, if I am replacing y is equal to 0 here, the value of p will become what? P also going to be 0. If I am replacing y is equal to infinity, infinity cube will become infinity only, so p also will become infinity. So the new limits are once again 0 to infinity only, undoubtedly. So now it's time to explore the integration value. What can we do? Take the integration. Let us proceed further. Same integration, we are traveling from 0 to infinity. E power minus y cube will going to be replaced by p now. Simply see there, e power, I am replacing this y cube by p, and this y power 1 by 2 will be replaced by p power 1 by 6. Let us see, e power minus p dot p power 1 by 6 dot dy is going to be replaced by 1 by 3 p power minus 2 by 3 into dp. Okay, sir. We are getting something value here. After that, what can I do, sir? Let us wait for a second. Let us try to bring the answer. E power minus p. Can we add this p power 1 by 6 with the p power minus 2 by 3 directly? If I will add, what you will be obtaining? 1 by 6 minus 2 by 3. See there? If I will do the LCM, here I am going to multiply it by 2 on both numerator and denominator, such that what you will be getting? 1 minus 4 by 6. The common value becomes 6. So further I can write this will going to be minus 3 by 6, or I can say it will be minus 1 by 2. Any doubt here? No, sir. So this will become minus 1 by 2. So I can write simply p power minus 1 by 2, and see that this 1 by 3 is constant. You can take it out. I can keep it here with respect to dp. Now we found one format here. See there, finally what is the answer that we got? The answer that we got here is e power minus p dot e power minus 1 by 2. Okay, sir, this is awesome. Now what can we do further? How can we solve this question further? Is there any idea to solve this question? Yes, there is some idea. What I am going to do is, always remember, anyway 1 by 3 is constant. I am going to do some changes in the expression. See that 0 to infinity. First I am taking p power minus 1 by 2. I am going to write this p power minus 1 by 2 like this. See there, minus 1 plus 1 by 2. Can I write like this? If you add minus 1 plus 1 by 2, what you will be getting? It will become once again minus 1 by 2 only. Undoubtedly it will be minus 1 by 2 only. Sir, why are you writing like this? Yes, wait a minute, slowly I will be telling you, because this is the first lecture. Slowly, while solving so many questions, you will be understanding, because this type of things will get repeated when you are solving multiple problems. Okay, sir. So from this I can write 0 to infinity, this p power, this can be further written as 1 by 2 minus 1. I am just interchanging the position of these two, into e power minus p dot dp. Okay, sir, we got some conclusion. Why are you doing this? What is the purpose? The purpose is, we are having some standard rule like gamma functions. You might have read this. Gamma function of n can be written as integration of 0 to infinity into p power n minus 1 dot e power minus p into dp. This is simply called gamma function. So here what can we do is, if you observe, if I am comparing this expression with this expression, see there we are having p power 1 by 2 minus 1. See, in place of n we are having 1 by 2 undoubtedly. So the value of n is 1 by 2. For this the value of n is 1 by 2. I can easily identify it. After that, see there n minus 1 e power minus p into dp. Everything is perfect. So it is almost similar. Both are same only. So in place of n, I can replace the n by 1 by 2. If I will replace n by 1 by 2, then here also n will be replaced by 1 by 2. So this whole function will be replaced by gamma of 1 by 2. So simply you can say gamma of 1 by 2. Now tell me, how many of you know the answer for gamma of 1 by 2? Just go through in internet or somewhere here, because it is very important to know about some fundamental basics. In integration, that's why we people are struggling, because we are not aware of some basic things. Anyway, don't worry, I will be covering all those basics. The way I am selecting the questions will help you to understand all the things that you are not aware of it. Okay. Okay, sir, fine. The conclusion is, let me tell you, gamma of 1 by 2 can be directly replaced by square root of pi. That's all. So you can replace this value by square root of pi such that your resultant answer will become square root of pi by 3. So this is the correct answer for the given question. I hope you all understood these things properly. This is all for this lecture. In the upcoming lecture, we will be dealing with a variety of integration questions in order to understand the complete integration. Okay. Remaining things we will see in the next class. Thank you all.